Good evening. Okay, so friends, I'm going to start. Okay, so today's agenda is to talk to you about what are the steps in carrying out aircraft conceptual design. Before that, just want to go through the timelines. I think there is some issue at my end. I'll try to sort it out. Okay, I hope the screen is visible. Can someone confirm?
Yes, sir, it's visible.
Great. So these are the guide, the all others may please mute themselves. Prachi, please take care of that. So as you all know, we started this competition, and then the first and the second stage, that is the initial report, initial registration, and the synopsis report submission is over, and the teams which have been shortlisted for task 1 or stage 1 and stage 3 are now working on the task 1 report submission. Now, if we look at the task 1 document, please confirm that you are able to see on my screen a PDF file containing the mission profile.
Yes, sir.
Correct. So this is the mission for which teams have to now go to the design of the aircraft. And these are the key mission definition. Okay. And I hope things are clear about it, because we have been operating our channel on WhatsApp, as well as we have a dedicated email address. So if you have any query, by now you would have probably given that. But just to go through, the specific objectives are that you are going to design a VTOL vehicle which meets the requirements to accommodate a patient and a paramedic. One very, very relevant example of that is what happened yesterday to Rishabh Pant. As you know, our budding cricketer, he met with a very massive road accident, and he was shifted to the nearby hospital. Then from there, he was shifted to Dehradun Max Hospital. And now there is a discussion that if required, using an air ambulance, he will be shifted to a much more capable hospital in New Delhi. This is exactly our use case. If there is some incident, a road accident, or any other issue, we should be able to reach out to that person very quickly and bring him or her to the nearby hospital on a stretcher. To make it amenable to reach remote areas, and we are wanting it to be within 10 by 10 meters and definitely within 12 by 12 meters. Then there is a means of compliance which are given in this website, which we have linked. We are expecting it to fly over rural and medium density urban suburban populations. We don't expect it to be flown in the peak urban scenario. Okay, and we want it to be fully autonomous with no onboard flight crew, and that is the biggest challenge. So the deliverables are also mentioned here. We are looking at trade-off analysis, looking at the features. We are looking at selection of the power plant energy storage system. We are looking at a weight statement and what are the critical areas. We are identifying what kind of exceptions to documentation you can give. And task 1, that is what you're going to do now, is design of the sub-assemblies, summary segment by segment of various performance issues, subsystem level performance data, 3-view drawings, sizing, including estimate of mass, takeoff weight, aerodynamic characteristics, flight envelope, then stability and control, trade-off analysis. All this is expected in stage 1, which is due about a month from now. Okay. So essentially, what you're going to see is you're going to do aircraft conceptual design. So today, my task is to just give you an idea on how we approach aircraft conceptual design. So generally, broadly speaking, the conceptual design exercise that we think of consists of 4 major elements. And I have chosen these elements because they correspond to an online course which I have recorded. And there is an NPTEL link for all of these courses, for all of these segments. So first we do initial sizing, in which we estimate the weight consumed in each segment of the flight by calculating the weight fractions. At the end, you can use all of it to get the first estimate of max takeoff weight and the fuel that you need to carry. But this is true only for an aircraft which consumes fuel during flight. But if you are using a battery operated system, then you do not have the luxury of doing a similar kind of a approach. In the aerodynamic estimation, once the vehicle configuration is decided, you need to calculate its parasite drag, get the CD versus CL curves and the drag polar, as it is called. Then you need to look at which are the constraints imposed on the system, which are most critical, and you draw charts where you can get the thrust to weight ratio and the wing loading corresponding to all of that. Now, this is true for conventional aircraft. Okay. Similar argument and logic has to be used by you to do it for the vehicle that is given to you. Then we have refined sizing, in which you calculate the updated L over D values because you now have TW and wing loading. So you can get a better estimate of max takeoff weight. So I repeat, this particular system or the formulae available for these in the various NPTEL courses which I have, which are available. I'll show you the list in the next few later on in the end. They are only meant for conventional aircraft, whereas your aircraft is not conventional. Your aircraft is actually unconventional. But I will tell you only about how it is done for conventional aircraft. Then similar approach you can now figure out for your aircraft. Okay. At any point of time, if any student has a doubt, please raise your hand so that Prachi can unmute you, and then you can actually ask your doubt, because I'm not able to see anything right now except the PPT that you are seeing. Okay. So I cannot see the chat window. I cannot see your hands, but Prachi, the co-host, can do it. And if you are not going to speak, you can type your doubt in the chat window. Prachi can also read out those things. When you do initial sizing of a conventional aircraft, the first thing you do is to get a good idea about the aspect ratio. And for that, here is a chart taken from the textbook by Dr. Daniel Raymer, where he says that you can actually first eyeball the aircraft based on the geometry and get the ratio of wetted area by the reference area. Okay. For example, if your aircraft looks like Beach Duchess, then your SWET by SRF is going to be approximately 7. If your aircraft looks like Boeing B-47, your SWET by SRF will be almost 8. SWET is the wetted area of the whole aircraft. That means the entire area that comes in contact with the air. And SREF is the wing reference area, which conventionally is supposed to be the area occupied by both the wings, including the portion inside the fuselage. So this ratio, based on history, can be found out. After that, Raymer also given a chart where for various kinds of aircraft, civil jets, subsonic, supersonic transports, fixed gear propeller, etc., he has given a graph of L by D max as a function of weighted aspect ratio. Now, going to the mission profile, just like you have a mission that I showed you a few minutes ago, you will have to do weight estimation for each segment. Okay. Then you have to determine what is the kind of, payload mass is, of course, something that you calculate from the requirements. And then there is the range and the endurance equations, which can be used by you. And using empirical data, you can get the estimate of the empty weight fraction. Unfortunately, you may not be able to get this data directly in any textbook for your aircraft because it is unconventional. So you will have to figure out now how we do these numbers for your aircraft. Now, it is a good idea to create rough parametric models because we are asking you to give a 3V diagram of the aircraft. So one can do that like this. We are expecting a diagram like this. This can be done using a software called as OpenVSP, which is a free software by NASA. In case students are interested, I can arrange a webinar by one of the, one of the team's members, one of the person in the team who has got some experience in conducting sessions for new students on OpenVSP. So if you want that, let me know. We will arrange a webinar by him somewhere in the near future, maybe by about mid-January. So this kind of 3-view diagrams we are expecting for your aircraft. We want you to determine the optimum trade-offs, and we want to refine the process so that we can get a more accurate estimate. Next, we move on to the aerodynamic analysis. Mainly, you are looking at two things: estimation of lift and estimation of drag. Both of them are through the coefficient CL and CD. For CL, there are standard procedures available. And for CD, you can look at the various drag components. In your case, wave drag will not be there because the aircraft is flying subsonic, but you will have parasitic drag and induced drag. What is parasitic drag, also called as profile drag? It is an umbrella term which is used to define 3 drag components. First of them is called as the skin friction drag, which occurs because of the friction between the ambient air and the body. So this depends upon the typical skin roughness and the extent or area over which the air is going to flow. Okay, so surface area and the skin roughness. Then we have form drag, also called as the pressure drag. Okay, here it is because of the cross-sectional area of the aircraft. Okay, so behind any body, based on the cross-section, there is going to be a wake, and that wake size determines the amount of drag which is created. So you can see that I've shown 3 aircraft cross-section here: Cessna 172, which is the ab initio trainer aircraft, then F-16, one of the very prominent fighter aircraft, and a large transport aircraft called as Boeing 747. Obviously, the frontal area of Cessna 172 being the least, at subsonic flow, it will have the least form or pressure drag, and Boeing 747 will have the largest one. So for form drag calculation, you basically need to minimize the cross-sectional area as faced by the air. And then you have interference drag, which occurs because of the interference between the various components. Now, the blue line here, which says depends on the frontal area of the body, is actually relevant for the form drag. Interference drag is relevant, depends on what is the kind of interference you can expect between wing and the fuselage, nacelle and the wing, and then horizontal tail and the vertical tail, etc. All components which are attached near each other. So for this, we have some standard procedures available, and one of the common procedures used by researchers and students in aircraft conceptual design is the component built-up method, where you calculate these components, the drag of each component, and then you just build it up together. Okay, so this is the general formula for the parasite drag coefficient, CDO. You have to do a summation of the component CF, skin friction drag coefficient, into component form factor, which takes care of the form drag, into wetted area. So this wetted area takes care of the skin friction drag. And then you have QC, which is the interference drag coefficient. All of this with reference to SREF. Then you have miscellaneous drag, and you have drag because of leakage and protuberances. Okay, so you have a skin friction coefficient which depends on Reynolds number. You have the form factor, which is geometry dependent. You have the wetted area of the aircraft, and you have the interference factor Q. Okay, so you can see that depending on how much is the interference between various components, you will have the drag at that place. Wave drag is not relevant to you because your flight is actually not supersonic. Finally, you just calculate the parabolic estimation, CD equal to C0 plus K1 CL square, where CD is the drag coefficient. K1 is dependent on the wing area, span, and sweep. It is essentially taking care of the induced drag, and CDO multiplied by the square of the lift coefficient. Okay. Now, the next step in conceptual design is constraint analysis, where we determine the thrust to weight ratio and the wing loading. Okay. Now, thrust to weight ratio is going to, it represents the output of the thrust divided by mass of the aircraft. This affects a few parameters like climb rate, turn rate, speed, power plant, etc. When you have high thrust to weight ratio, you have higher maneuverability also, because you can get larger thrust for a given weight. Wing loading is mass of the aircraft divided by the wing area, wing reference area. This affects stalling, climbing, sealing. It also affects takeoff, ground roll, and landing roll, etc. High wing loading is not a very good idea for high-speed aircraft, but it gives good takeoff and landing performance. The next step is, as I mentioned, you have to look at all the constraints which are relevant to you. This list is not relevant completely to your aircraft, but generally it is relevant to a military aircraft. So you have to look at, so for example, these three constraints are not relevant for air ambulance. Okay, you don't have to worry about them. So there is a master equation which can be used to calculate the T by W for various configurations. Okay, this includes terms like beta, which is the weight fraction, then alpha, which is the thrust factor. Then you have dynamic pressure, you have the parasite drag coefficient, induced drag coefficient, load factor, velocity, rate of climb, acceleration due to gravity, and acceleration. All these terms are, entangled together. For example, if you look at subsonic turn rate, let us say you are looking at turn at Mach number 0.8. Again, I'm not giving you an example relevant to your aircraft because I want to avoid that. I just want to tell you the procedure for a generic aircraft. So if you are looking at subsonic turn rate at level flight, then there is no acceleration, there is no height change. So those two terms become zero. And then you can get a correlation between T by W versus W by S. And you can get a graph like this where the marked area, red area, is the feasible zone. For max climb rate, you have, again, ROC will be dH by dt, which is the climb rate. Other terms, the acceleration term will vanish, and you will get a graph like this where the entire green area is feasible. So you can see here that in this particular example, which we have shown, the the green area is actually encompassing the red area. Okay. After that, we do refined sizing, because when we do constraint analysis, you have better estimates. And then we can use, because W by S and T by W are known, we can use them for better estimates of L by D, and then you can use it for areas. Now, coming to your problem. So what we have discussed so far are methods exclusively for fixed wing aircraft. So for your case, you have to identify what is the correct procedure. You have two issues. One issue is that your aircraft is a kind of a VTOL aircraft. And secondly, it also has some electrical propulsion. Okay. So you can refer to some of the books which are available for classical helicopter analysis and design. These are some books which I know about. There could be better and new books also, which I would like you to search yourselves. Okay. Right. Now, there are some resources available to you. There are two NPTEL courses on aircraft conceptual design or aircraft design. One is by Professor Ghosh from IIT Kanpur, and the other is by me. There are some textbooks also. Unfortunately, these textbooks are relevant only for conventional aircraft, except the last one, which is only for UAVs. There is another book, which is the book by Jenkinson, Simkin, and Rhodes, who have given some case studies also. So there you might find something useful and relevant to you, which you can follow. Okay. So with that, I come to the end of the presentation that I wanted to give you. But now we will be happy to take any queries that you may have. Okay. So now the floor is open for any queries that anybody has. I am going to allow you to unmute yourselves. So you can just raise your hands first. And then once you raise your hands, I will be unmuting you one by one, and then you can speak, or you can now start typing in the text in the chat window also. So the floor is open for any queries. Sampati Rao. Yes,
Hello, good evening, sir. This is
go ahead,
Sandeep
please.
from. Yeah, so I have like two questions. Like, what is the altitude at which this aircraft is operating?
That is left to you. See, you have to look at the document. You have to look at the document shared with you as a problem statement. If it does not mention a specific altitude, you decide how much high you want it to go. Because see, its mission is just to transfer the passenger and the paramedic from the site of pickup to the nearest hospital. So it is up to
Yes,
you.
yes.
We don't
Okay,
want to give you a number.
okay. It's like my got this question because like designing in say some region like in Himalayan region, designing there will be slightly different when compared to there because of temperature effects, etc. Right?
No,
So
no, but unless anything is mentioned, you should assume ISS sea level conditions.
okay, okay,
So you don't have to impose unnecessarily any height constraints.
okay. Sir. And is there any
Okay.
time constraint also? Because this is a like transferring a patient from to the hospital. So shouldn't
We
there
have
be a
given you
time?
the speed. We have given you the speed and given you the distance.
Okay. Yes, yes,
So
yes.
from there you
Okay.
have to figure out.
Yes, yes, yes. Got it, sir. Got it.
Okay.
Yes.
There are some questions in the chat window. I'll take them one by one. One question is about low fidelity model description. So this I'll just explain to you. Basically, what I mean by low fidelity model description, or what we mean by that, is that there is something called as low fidelity, medium fidelity, and high fidelity. By fidelity, we mean accuracy of information and modeling. So when you say low fidelity model description, it only means that in the initial stage one, you will be using simple formulae and simple approaches. So just describe those formulae and method to us. That's all we are asking. So that is the meaning of low fidelity model description. Okay. Then Sai Hemant Yagna Kashyap has said flight envelope and low fidelity model description. So one I have already answered. By flight envelope, we mean what is the curve between the speed and the altitude within which your aircraft can operate. That is it's like a height, operating height versus the speed diagram. This is one flight envelope that you can use. Okay. Harsh has a question about how detailed should the internal cabin be designed. Is it sufficient to mention what equipment will be placed where, or we have to design everything? No, in this particular stage, you don't have to design in detail because this is stage one. In this particular, this one, what you should do is try to give an approximate layout by maybe just a 2D top view diagram mentioning various equipment. What you can do, you can number the equipment and you can give a table saying number one is this, number two is this is the weight we have assumed, and this is the dimension we have assumed, length, weight, height, and the dimension, if it's available. That's all we want. Later on, once you are shortlisted for stage two, we would expect you to make a proper CAD model of the whole cabin and give it to us, but not in stage one. Okay, Sanidhya has a question about is the power plant of an aircraft must be electrical or both fuel and electrical? Please read the problem statement carefully. It is mentioned there. You have a choice. You can make it as only electrical. You can also make it as hybrid. So we are not asking you to make it either fully electrical or fully fuel. It's up to you. Then Phoenix says that can we assume a high specific energy battery like 5,500 watt hour per kg, which may be available in the far future? No, don't go for far future. Go for only near future. Okay, we would expect you to design this. We would expect you to give us the assume the values which are relevant, which should come into fruition in the next 10 years. Okay, so what you do is try to give technologies which are definitely going to be available by 2032 as per the projections given. That is what we are looking for. But if you simply assume some huge number, which will take more than 10 years to come in the market. See, there are some technologies which are, so we have what is called as technology readiness level, or TRL. So you have to look at items or equipment which are at least TRL 7 or TRL 8 in the next 10 years. Items which are in TRL 1 and 2, etc., they will take much more time to come into market. We are not looking at research, we are looking at the market. You should be able to buy those things. Sayyid Mujahideen says, stability and control. I don't understand. Probably you are saying how to do stability control analysis. Well, you will have to refer to the standard textbooks and follow the procedure. I don't have a ready answer for this because the aircraft is also unconventional. However, in the first stage, I don't think we are expecting you to do any great stability and control analysis. Harsh wants to know easy approach to select a propeller. Well, Harsh, I don't have any ready-made answer also for this. You will have to look up at various standard handbooks. In fact, if you want, we can request one of our propulsion experts to arrange a webinar on this topic. This could be a topic for a webinar in case you are interested in that. And in case this is a burning issue with most of the team members. So we have a WhatsApp group, we have a dedicated email address. If many team feel that they would like to learn how to select a propeller, then we will try to approach some propeller experts and get them on board to give their presentation. Otherwise, I would suggest that you look at standard textbooks and or standard procedures where you might be able to get the answer. Okay. Anybody else would like to ask anything? Please raise your hands.
So there is one more question in chat.
In chat. Okay. I'm not able to see. Okay. So Prachi, can you read that question, please?
Yes, sir. This from Srujana. What specifications should we verify with the EASA conditions at this stage?
Please look at that website and follow the procedure listed there. We have given you a link to a website. So basically that website gives you some kind of a idea about the constraints you have to consider. So just try to follow whatever you can from the website.
So someone suggested a webinar on UAV might be helpful.
Webinar on UAV might be helpful, but what aspect of UAV? See, we will not be able to conduct a webinar specifically on the topic that you are.
UAV.
Okay, so please send an email to us officially in that email address, and then mention exactly what aspects you would like the speaker to cover. Then we will find an expert and request them to give a webinar on that.
So Dhruv is asking, does lofting come under conceptual design?
Lofting.
Yes,
Lofting. Yeah, but see, nowadays we don't do hand lofting, we do computer-based lofting. And in stage one, I don't think in stage one we are looking at detailed computer-based lofting also. I think some people mic is not muted. Please be careful. You are on a webinar. Other people are listening. Please mute yourself. We will unmute only those who are speaking. So I would like to ask one question. So I would like the leaders of each team to just raise their hands so that we can know from which team they are and from what college. So all the leaders, please raise your hand. So some Sai Sandeep, where are you from? What team and which college?
I'm from Team Jatayu from IIT Madras.
Team Jatayu from IIT Madras. Okay. Then Samriddhi.
Sir, Team Jettison from IISc Shibpur.
Very good, very good. I'm happy that there is someone from Shibpur. Okay, Rishi Bhagat.
Sir, Team Lakshya from Jain University.
Jain University, Bengaluru.
Yeah.
Okay. What about Prathamesh, Auxilium?
So we are Team Auxilium from School of Aeronautics, Neemrana, Rajasthan.
Neemrana. Okay. Rishi Bhagat.
Sir, that only. Jain University. Team
Oh,
Lakshya.
I'm sorry. I'm sorry. I did not put your hand down. Huh? KM Monica.
Sir, Team Metal Hawk, Business College of Engineering.
Team Metal Hawk. Okay. Okay. Very good. So that is Sandhya, right?
Yes, sir. Team
Okay.
Falcoholics from Agni College of Technology, Chennai.
Chennai. Okay. Lakshmidhar Gedam.
So Team Matrix from Bharat University, Chennai.
Which university? Chennai, sorry.
Bharat University.
Bharat University from Chennai. Okay. Harsh.
Sir, Team Madwings from MIT Manipal.
MIT Manipal. Sagar Prabhuraj K.
So Team Pandu from Dayanand Sagar College of Engineering.
Pandu UAV. They last year also they were the same name. Okay.
Yes.
Sayyid Mujahid.
Sir, Team Skypian from Global Academy of Technology, Bangalore.
Bangalore. Okay. Then we have someone called 1+ CPS 2381. So
Yes, sir. We are Team
what is your
Hanuman
name?
from Anna Sahib Dange College of Engineering and Technology, Ashta, Maharashtra.
ADCET. Okay. Karan Singh.
Sir, we are from Punjab Engineering College, Chandigarh. And Team
Okay.
Strike.
Neeraj PS.
Sir, Team Rakshak from Gopalan College of Engineering and Management, Bangalore.
Okay. There is a question from Phoenix. And the question is, can we also work on increasing the passenger, that is number of patients? No, we should not do that. You should never do more than what is asked. Okay. Always remember that in aircraft design, doing more than what is needed is a waste, and you will compromise your solution. You will not, there'll be somebody better than you. So don't do that. Just do it for what you have been told. Manikant. Manikant, where are you from? Which team?
With me, but sorry, but I never got to be in a club. I'm gonna join. Let's go.
Okay, Navya Sharma, can you please mute yourself? I think. Okay, Jaydev Reddy. Yes, Jaydev. You can type in the chat window also in case you have a problem with audio. Vignesh P.
Good evening, sir.
Yes.
Good evening, sir. I'm Team Thunderbirds from Sri Ramakrishna Engineering College, Coimbatore.
Okay. Rinisha Nikhade. Rinisha. Pranav Santaki.
I'm from Team again from KCG College of Technology, Chennai.
Okay. KCG in Chennai or in Coimbatore?
No, sir, Chennai. KCG College of Technology.
Okay. Devyant Singh.
Yes, sir. I am from Winged Warrior from Sir MIT University, Noida.
MIT Noida. Bhavya Majumdar.
Good evening, sir.
Yes.
I'm from Team Innovators, MIT ADT University, Pune.
Pune. Okay. Bhavya Majumdar. Okay. Then we have Suraj. Suraj. Okay. Lalit Dontham Setti, he was the first person to join the webinar today. Yes, Lalit.
Yes. Sir, we are from Team Asclepius IIST.
IIST Trivandrum.
Yes, sir.
Okay. Right. Prince Verma.
Good evening, sir.
Yes.
Sir, we are Team Aero Indians from Chandigarh University.
Chandigarh University. Okay. Sri Priya K.
Yes.
Good evening, sir. We are from Team Abhimanyu from MBJ College of Engineering, Bangalore.
Oh, you are the champions.
Thank you, sir.
You have a very good legacy. Your seniors have performed very well.
Thank you,
Okay.
sir.
Then we have Galaxy J7 Prime. Obviously, it's the phone. So who is this?
Sir, good evening, sir. Sir, we are team Aero Unicorn from Parul University.
So you can actually rename yourself. Okay.
Yes, sir.
So I have allowed you now. You can rename Renisha Nekhade.
Yes, sir. Good evening. We are team I am Ruth from Defense Institute of Advanced Technology, Pune.
Oh, DIAT Pune. Very good. Your team has performed very well in the last competition, and they were actually, they have done quite well. I remember. And there's a new entry. Second time your college is nominating someone. Okay, very good. Okay, so I think if there is anybody I have missed out, any team leader whose name I did not call, this is the time for you to unmute yourself or raise your hand, and we will unmute you. Okay. I don't see any hands being raised. Okay, fine. So the floor is open in case there is any other point you want to discuss. I would like to know. Okay, there are people who have typed. Very good. There are many who have typed. Okay, so Sandeep University Nashik has a team. DIAT Vayumrit, Vayu from Rugnavan, Manikant from Lakshya Hyderabad, IAE Hyderabad, BMCE Bengaluru, Team Safira from IIT Bombay, Aero Unicorn from Parul. Okay. I have answered the question regarding increasing number of patients, or we stick to the mission. Yes, Dixit, yes.
Hello? One more
Yeah.
team, Tech Giant from IIT Kanpur, sir.
Yes. Then there is KLS JT from Belgaum Times Vayuputra, Team Akashi from Shastra University. MHAN wants to know, can we make changes in the cabin design that is more or less than 3 meter by 2 meter by 1.5? No, that is a requirement. Unless you show that that area is insufficient. This is the minimum area we want. You can give more than this if you can justify that. Without this, it will not work. So normally you should go by what is given. Okay. Right?
Hello.
Yes.
Hello, sir. One more question regarding the
Yes.
mission profile.
Yeah.
So if I understand correctly, during the transition, it goes from like the horizontal speed is from 0 to, it is accelerating to V stall, and it goes an accelerated climb from V stall to the cruise speed.
But where is it mentioned?
Like in the mission statement, you told that until V stall, right? In the mission profile diagram.
No, wait a minute. I'm going to, I don't know. I don't remember about mentioning in the mission statement about stall. So what we can do is, see, we should go purely by the documentation. So let me just see in the notification page. Let me just search 1 minute. 1 minute. I don't see the word stall in the whole mission statement. So where did you get this information regarding stalling?
In the mission profile diagrams.
In the mission profile diagram. Okay. 1 minute. Yes. Okay. Yeah, correct. You are right. You transition up to V-stall and then you climb. Okay. So what is your question?
But just wanted to confirm whether my understanding is correct. Like accelerating to V stall and then an accelerated climb from V stall to V cruise.
Yes, that is what is mentioned there.
Yeah. Okay, sir. I just wanted to confirm that.
You have seen the screen now?
Yes, sir. Yes.
So you take off from the ground in the vertical mode up to 1 to 2. Then you, because you are at 0 speed, you proceed up to V stall. Now, below V stall, if you start flying, there will be a problem. So you go up to V stall and then you start climbing. I am not mentioning about accelerated climb. I'm just saying climb. You decide whether it is accelerated or whether it is a normal climb, and then cruise and then descent. So this acceleration and climb I don't know whether it will be detrimental for the passenger. So it is up to you.
Yes, sir. Okay. Okay.
Okay. Next query. Yeah. Any other question? I have a question to ask all the teams. Our deadline for submission is 31st of January. How many teams are having any serious commitments during the month of January? What do you have in January? Okay, Monica, what do you have in January?
Sir, my SEM exams are going to be started, sir.
From what date to what date?
Sir, from 5th of January to 31st January.
Final examinations.
Sir?
You're going to have an examinations.
Sir, I couldn't hear you, sir. Sorry,
You are going to have your college examinations.
Yes, sir. Yes, sir. SEM
So
and
these are
exam.
internal or external?
External.
Are these internal? Are these external or internal?
External examinations, sir.
And do you have examination every day?
No, sir.
There will be gaps. How many papers do you have? How many subjects are there?
Sir, 8 subjects, sir.
8 subjects. Okay. Right. So the only thing I can suggest is that you have to use the time in between. And in the end, if your faculty mentor writes to us, we might be able to give you some extension. Okay. Sagar Prabhuraj.
Yes, sir. Thank you, sir.
Yeah, we'll definitely be able to help you in case there is a genuine requirement. Sagar Prabhuraj.
Sir, we have our exams from 25th of January.
Okay, that is quite far away. So I think you can use
Yes,
the
sir.
initial part. Okay. Sri Priya.
Yes.
We have our exams from 16th and lab exams from 8th of January.
No, up to what date? From 16 to?
Up to 28th, sir.
Okay, fine. So you can request your mentor to send us an email with some kind of a timetable to be attached. We will see what best we can do. But continue working till you can. Okay, don't assume that anything will be given. Arnav Santaki, what do you have? Arnav, unfortunately, your audio is not clear, at least to me. So you can type in the chat window. I will ask Susovan Panda.
Yes, sir. I'm from Auxilium team, and we have a training of MRO, and it is started from 21 December to 15th Feb. So full January is an MRO training, and as well as in January, we also examinations, college examinations also.
Yeah, so then I don't know what I can do. I don't know. I don't know whether you can take part in the competition because we cannot take care of such things. But when you say you have MRO training, what does it mean? You are going to be away from college whole day?
Sir, MRO training is like 9 to 5. So, and the college is providing us the training, so that's why they will help us to do that.
So unfortunately, we cannot do much. If you are busy from 21st December to February, then if you are not able to find time, we really can't help. You cannot do much about it. So you try to find time and do it if you want to take part in the competition.
Obviously, sir.
Okay.
Thank you.
Anybody else? So those of you who have expressed your constraints to me, please send an email through your faculty advisor, faculty mentor, to the NACDeC address. Give us the specific dates of the engagement and give us the documentary proof of those. then we will get it done, and we will try to see what we can. Okay. Phoenix says that you have a week full of internals and labs. So 1 week is not really too much of a time. You have a whole month available to you. Okay. Then there is a question from Prathamesh. Aircraft is fully autonomous. Can we provide a start or standby mechanism in the place of accident? Yes, we do have to do that. You are right. The system has to be started. So I think some kind of a switch has to be provided so that once the that switch can also be inside the aircraft, which can be operated by the paramedic. Once the switch is operated, the aircraft then starts going ahead. So that is a good idea. Because it is autonomous, we need to have some facility there like that. Okay. Any other question anybody has? If there are no questions, then we can stop the webinar and wish everyone a very happy new year in advance, and see you again next year. We are looking for your emails requesting the topics to be covered in the webinar. And if you give us enough time, then we can approach the experts and request them to do it. The next webinar will be planned somewhere in the 3rd week of January, maybe about 10 days before the submission deadline, so that suggestions and hints can be, or if you wish, we can have it a little bit early also. But I think we will need time till at least mid-January to locate. After you send us what you need, we have to start searching, and then we will be able to proceed further. Okay, so I would like to know if there is any other query, and also I would like to open the floor to Abhishek, Dr. Ramchandra, if they would like to add something or say something.
Yeah, Dr. Pant Ramchandra, good evening to all of you. And it was good interacting with you, and I'm sure Dr. Pant had a good time interacting with the teams. And I am very happy that there are so many teams and almost good spread all over the country, and that's a good thing for the competition. It spreads the message all over, and that's the first observation I had, Dr. Pant. Maybe Dr. Abhishek has something to say.
Abhishek.
Yeah, good evening, everyone. And I think it's a really good webinar, and it's really heartening to see, so many teams coming in. I don't have anything much to add. Just I'd like to wish everybody a happy new year in advance.
Yeah, actually, Professor Abhishek is himself an expert in VTOL systems. So we might request him to take a webinar sometime in the near future. He has done some very path-breaking and interesting work in this field for UAVs and delivery UAVs also. Dr. Rajashekhar, I see that you are there and you have been very regular in the webinars. Would you like to add something, sir?
I'm in travel actually.
Sir, you are on travel, but still, if you want to say a few words, it's fine. If you are not able to, it's all right. We'll open the floor to other people. We have about 5 minutes, 8 minutes remaining before we wind up. Okay. Anybody else would like to say anything? Prachi is also there along with Pranav. Both of them are doing all the coordination work. They are fantastic group of people. We also have in the webinar Ajit Kumar Shetri, who is our very active volunteer. If they want to say something, please tell us about your initiatives on the social media. Pranav, would you like to speak something? Prachi, what about you?
Hello, sir, am I audible?
Yes, you're audible, Prachi.
Nothing. I would just like to say all the participants that be interactive on the WhatsApp group regarding the doubts and use also the email for all this purpose, and also follow our social media for the updates.
Okay. So last chance for anyone to speak before we stop the meeting. You can simply unmute yourself and speak. So Sagar Prabhuraj says, are the synopsis reports graded? Sagar, no. The synopsis reports were only reviewed to see whether there is any team which has not done anything worth and they are frivolous. So you'll be surprised that there were teams which have given us a 2-page report on pre-synopsis. Such teams we have, and I will just say there are very few teams like that. So we have mostly not, worried much about grading the reports. It was simply go and no go. So few reports did not meet our go requirements, so they were discontinued. But we have not done any grading because synopsis report was only meant to identify teams which are serious and teams which are non-serious. And it has served the purpose. But very good questions, Sagar Prabhuraj. Okay, any other point? So Prathamesh has a question. Will the number of pages please be exceeded in any case? What do you mean? Are you saying that we are very strict about the page numbers? Yes, we are very strict about the page numbers because we have to check so many reports and we don't want to be loaded with so much of material. You have to decide with your team what aspects will be highlighted, what aspects will not be highlighted. Therefore, you have to strictly limit your report within the page limit which we have specified.
Sir, excuse me.
Yes.
Sir, so again, the page limit is excluding that appendix page and the certificate page and all those, right?
No. Appendix is counted because you can push a lot of things in the appendix unnecessarily. So the top page you have to mention the team details and nowhere else the team details should come. So that top page is not counted. And you will have in the end maybe some page saying thank you or acknowledgements. That is also not counted. Right from the page which has abstract, then contents. After that, you'll have the whole report. Then you have references and you may have appendixes. All of them are counted. Harsh has a very interesting question. Can we get the previous NACDeC reports from teams which won? Yes, Harsh, we will try to approach those teams, take their permission, and if they give permission, we will share their reports because some teams who have won the competition, they are working further and writing publications out of it or papers out of it. They may not like us to share. So therefore, we will take approval from the teams. So Prachi and Pranav, this is your task now. We have to identify which team members from the previous winners are agreeing to give their reports, and then we will put the reports on the web page.
Okay, sir.
Monica says, will this webinar be available on YouTube? No, it's not on YouTube, but it will be loaded on the web page because I have recorded the webinar unlike last time. So we will put it in our web page. So it will be available for other members, but not on YouTube. Dhruv Pendharkar.
So I had a question from the problem statement.
Yeah.
So in the special deliverable section, there is a point that says identification and justification of all exceptions to project technical requirements. Could you please throw some light on this?
See, based on your study, if you find that certain requirement that we have given is absolutely not meetable, and if you have solid justifications for that, then you can mention that in your report. We will review it. We will see if it makes sense to us. So what we are saying is that the problem statement has been made by us based on some assumptions and based on certain expectations. We have not actually done the whole problem solution ourselves. We have not designed this aircraft. We have only made the problem statement. Sometimes while making problem statements, you start demanding things which are contradictory or which are unexpectedly very, very difficult to provide. If you identify any such thing, you can use our WhatsApp group as well as the mail to clarify those doubts. And if you feel that, you can justify that they should not be included, put it in your report and say, this requirement we think should not be met because blah, 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 blah. We will consider it. So we are giving you a chance to comment on the problem statement. What we would really prefer is if your comments are given first on the website and on the WhatsApp group, so that everybody comes to know, and there may be some other teams who will have the same problem. So that would be preferable.
So essentially, if it is thoroughly justified, there's some room for relaxations and design requirements. Right?
Correct. See, we have given some requirements literally from top of our head. Okay. We have not designed any system like this ourselves. So we don't know whether something that we have asked is completely unreasonable. For example, if you prove that within the dimensions mentioned for the cabin, it is impossible to fit all the equipment, great, you show us. You can just draw a diagram and say, look, I put everything in the diagram and the area is more than 10 by 10 or 12 by 12. So then we will look at it and we will say, okay, then we will relax it. So basically, you try to prove to us, if possible, that some of the requirements are unrealistic, unachievable. We are open to modify them because it is not cast in stone. It is all an imaginary, from our own experience and our own imagination, we have come up with the problem statement.
Thank you.
Okay, Dhruv, thank you so much. All right, friends. So I think it's time for us to say goodbye. I am very thankful to all the, right now there are 65 people in the meeting, but there were at some point around 75 people in the meeting, or more than that. So it's great to have you on the New Year's Eve. So be safe, enjoy responsibly, and all the best. Wishing all of you a very happy New Year in advance, and we'll again interact in 2023. Thank you so much and goodbye. I'm stopping the meeting.